Resting land won't restore biodiversity. We are currently living through a biodiversity crisis. The vast complexity of life, from mammals to the microorganisms in our soils, are declining at dangerous rates. While biodiversity is often associated with saving a handful of endangered species, the biodiversity crisis is in fact destabilizing the very systems that support all life on Earth. But there's a solution, right? Leave it alone and make sure not to disturb it. Decrease animal numbers and allow the land to rest. Or so we thought. Rest has become one of the primary tools we use to try to halt biodiversity loss and environmental degradation. We see this story all over, time and time again. But could there be a missing piece of the story? What if resting land was actually destroying biodiversity, allowing deserts to spread, fires to expand, and accelerating climate change? To understand this better, let's first clarify what resting land really means. Rest can mean different things, but it's often related to the absence of disturbance, from grazing animals, fire, human presence, or other disturbances. For the presence of grazing animals, there are two types of rest: partial rest and total rest. Partial rest happens when animals are present but in low numbers, or scattered most of the time. Total rest means animals are completely absent. We often hear about the problem of too many animals in national parks, in pastoral systems, or on farmland. And the instinctive response is, get them off the land and let's rest it. And yes, that can be beneficial in some contexts, but in most cases actually, it's only half the story. This brings me to a topic I've covered previously on my channel, the concept of the brittleness scale. The effects of resting land in Britain or Costa Rica would be very different to resting land in Zimbabwe or the majority of Australia. Put simply, Costa Rica being low on the brittleness scale, meaning it receives consistent rainfall throughout the year, allowing for quick and consistent decay of plant material year-round, cycling it back into the soil. Here we see animals like anteaters, sloths, monkeys, and solitary predators such as jaguars or ocelots. Where resting land in these environments are the most powerful tool we have to restore biodiversity, leave the rainfall to rest and biodiversity eventually comes back in full force. Comparing that to the other side of the scale, higher brittle environments such as the iconic savanna landscape of East Africa or the Central Asian steppe. Here we see highly erratic rainfall leading to dry, extended periods of around 8 months depending on the location. But long dry periods mean slow decay and needs disturbance. Dead plants don't rot or decompose, they just stand there choking out new growth and becoming fuel for wildfires. Hence, in these areas we find massive herds of grazing animals, millions of wildebeest, zebra, impala, elephants, which trample, graze, and digest this buildup of plant material. And within these brittle environments we see a different type of predator pop up. Pack hunting predators, lions, wild dogs, spotted hyenas, and wolves. These predators greatly impact the behavior of these big herds by keeping them bunched together and constantly moving. This type of herd effect is what has kept grasslands healthy for millennia. See, while partial and total rest would restore biodiversity in non-brittle environments such as Costa Rica, the opposite is true in a brittle environment. You might be asking by now, why are you telling me all this? Who cares? Well, roughly 2/3 of the world's land surface is semi to highly brittle, and these vast areas have already been desertifying at alarming rates. And there's another problem. The wild animals that used to keep these grasslands healthy just aren't there in the numbers they used to be. And in many places, the great grazing herds are in a tiny fraction of what they once were. So now we have the problem of not enough animal impact to recycle all the plant material that builds up every year. That dead grass doesn't magically disappear. It blocks new growth and turns into the perfect fuel for fire, leading to the massive unnatural increase of wildfires across the world. Yet we often see policies and management decisions that keep brittle regions stuck in partial and total rest. An example of this was in New Mexico, where livestock were removed back in the mid-1900s, with the goal of letting nature recover and prevent erosion. But the grasslands still kept degrading.
Okay, well, I'm now inside one of these experimental plots that was put in by the Bureau of Land Management in the 30s, and that's the outside of the plot. This is the inside. This is where cattle have been completely excluded now for 50 years. As we saw in the 1981 report on desertification, the picture taken in the 30s showed this to be extremely vigorous grassland because we'd had very high animal numbers that the government was wanting to destock. They'd stopped the overgrazing of plants on this side, and we had that marked contrast. Now that contrast lasts for 3 or 4 years because you have the residual effect of the animals. Now we're looking at it after 50 years of rest, and as we can see, there's essentially almost no difference between these two sides, because out here the government destocked drastically, and in here they destocked totally.
Most of us have always believed that removing animals from the land and resting it is the same as protecting it. Allan shows us why, in seasonal rainfall environments, resting land actually kills perennial grasses and destroys biodiversity.
But we're beginning to see pockets of change. Farmers, ranchers, conservationists are using animal impact to restore, regenerate, and improve biodiversity. While our management and policies still promote rest as the main tool to restore biodiversity, that simply isn't the case for brittle environments. With that, we're seeing the crazy amounts of human and non-human induced fires around the world. The nature we're so desperately trying to protect is going up in flames. But more on that in another video. So that's why brittle environments evolutionarily rely on the biological decay from large herds of grazing animals to maintain healthy soils and preventing biodiversity loss, not rest or fire. And as biodiversity loss, climate change, and desertification worsen, the need to understand the tools at our disposal and their consequences has never been greater.